He has been the CIO and the vice president of 4 or 6 universities at least. I don't know how he can do such many things at the same time. He is right now the vice president in the Polytechnical, the Florida Polytechnic University, and he's the CIO, the information officer of the university. And I learned 1 week, 2 weeks ago, that he is also the chief technological officer in the electronics. That's recent from the
Moffitt
cancer, which didn't tell me that I was told that the budget is $1 billion. So this is the guy that created the largest lab of its kind in the United States in 3D printing. I really, you can enjoy it. You're gonna enjoy his talk. Thank you so much.
Very nice, Najee. Thank you very much. So my name's Tom Hull. Feel free to raise your hand or ask questions as we go along. Myself and Dr. Chris Yakimishin, who is a PhD in electrical engineering, a professor in some of the other things that he told you about. He also holds 40 patents in various things. So we're going to kind of go back and forth and talk about 3D printing and how it's now being used in education. And to the point that Najee was just making, we're going to talk about the Innovation Center that has over 60 3D printers. We'll talk about that and how they're being used in education. And also, you mentioned healthcare. So I'm the CTO at Moffitt Health System. Moffitt is in the United States is a national cancer institute, and it includes a hospital, oncology research, physicians and professors as an academic medical center that focus on the treatment and prevention of cancer in the United States. And there's many people that come from all over the world to get cancer treatment. Right here in Tampa, about an hour away from here, is where Moffitt Cancer Center is. So we'll talk about how 3D printers are now being used in healthcare, manufacturing, and education, and may give you some ideas as it relates to what you do at your university or in your country.
Email too, right?
Yeah, Dr.
No, not the email, just the name and the signature.
Okay, all right.
Okay, so here's the agenda, 3D printing now and in the future. We've got a lot of slides, so we're going to try to move pretty fast and yet try to stay on time.
Will the slides be available at some point?
Yeah, we'll have the slides available. We'll make sure the slides.
Yeah, they will be.
Okay.
All the plenary sessions slides will be available
We'll talk about
with the video.
Oh,
the
okay.
Florida Poly story, hype cycle, 3D printing in healthcare, manufacturing, and education, recent industry announcements, materials and filaments, latest technology and products. So 3D printing, everybody's heard of 3D printing? Have you used it? Anybody used it? Okay, you've heard of it. It's kind of like personal computers were in the 1980s. Everybody remember the 1980s? In the 1980s, nobody was sure, should I buy a computer? Should I not buy a computer? Universities were like, well, should we have a computer lab? Right? Every university now has computer labs with PCs with a lot of software, right? When we put Florida Polytechnic together, we built several computer labs. But in the 1980s, there was not a lot of software. There was not a lot of reason other than maybe Word documents, word processing to have a computer. And it's kind of like here today. 3D printing has been around for a while, but desktop 3D printing just came about in the last decade. Now it's become more popular because of things like this, the desktop 3D printer. So now people are starting to get personal use out of 3D printing. So pretty soon, my my prediction is that universities will all be considering having a 3D printing lab at their university. When we started this university, 3 years ago we started planning it. We just opened it 2 years ago. But 3 years ago, one of the innovation labs that we created was this 3D printing lab. To Najib's point, it's the biggest in the country. We took the opportunity to do that. I'll show you pictures. But the reason we did that was because of some of these predictions. By 2019, 10% of people in the developed world will be living with 3D printed items on their bodies. Also by 2019, 3D printing will be a critical tool in over 35% of surgical procedures, including prosthetics and implanted devices placed in and around the body. By 2019, technological and material innovation will result in 10% of counterfeit drugs and pharmaceuticals being produced by 3D printers. So it's not just the plastic filament, it's other types of materials that are going to be produced in 3D printers. 10% of discrete manufacturers will use 3D printers to produce parts and products in the products that they sell or service. That's a lot, 10%. And then 10% of out-of-production spare parts for cars, trucks, bicycles, motorcycles, military vehicles, drones, will all be made on 3D printers. The analysis was, since 3D printing was invented, it's been used primarily for prototyping. Since the last decade, now people are starting to get creative. Just like computers, people are starting to get creative. Like in the 1990s, you could not live without a PC, and even especially today. We see that now in 3D printing. We're getting more and more creative with the filaments and the other use cases in healthcare and manufacturing. So hearing aids, dental implants, braces, prosthetic limbs, we're seeing these today. There are people, let's say you lost your hand or even a finger, you can have a well-printed prosthetic device that's not electrical, it's just mechanical, that actually does something, that actually simulates the movement of your hand or your finger from the wrist down. There's many examples of that. It's great for people that are impaired in some way physically to have very inexpensive prosthetic devices. They don't have to cost a lot of money now. You can actually print very affordable ones. So again, 3D printing, in case you didn't know, is an additive technique, right? So that means instead of like a CNC machine, everybody CNC machines in manufacturing, you take a block of metal and you trim it, you cut it to make the device or the shape of an object that you want. 3D printing, you're starting with nothing and you add layers on top. Chris is going to talk more about the different types of that. So, it used to be that 3D printers were very expensive, up to $1 million. There's still $1 million printers. There are those supercomputers of 3D printers. But now you can get 3D printers for less than $500.
Now you can make, we talk about plastic here, now you're indicating that you could print, here goes the language again, print metal things, for example.
Composites, metallics. Composites would be a combination of what's called PLA plastic or ABS plastic. ABS is more rigid. PLA is plant-based. You insert different metallic pieces or wood grain pieces. You can have a wooden type of object that's a composite.
So you could print one of these.
You could print one of those. Yes, indeed. Yes. Chris has used semiconductor conductive filament that will actually carry an electrical charge. So that's very cool. So how does that affect us when we plan? Well, it means that we can't ignore 3D printing as a technology for the very near here, this is from Gartner, CIOs and enterprise architects in healthcare and manufacturing have got to plan for this disruptive effects of 3D printing. The things that are going to happen in the next 3 years, services and competitive environment that's going to be result in advances in 3D printing. CTOs, COOs within healthcare and manufacturing, they must consider that materials that will not only produce finished goods, but will augment their production processes. So these are medical device manufacturing. Investors must stay abreast of disruptive technologies, disruptive advances in 3D printing technologies. And again, will result in a wide range of healthcare products and manufactured goods. Okay, so the next part, I wanted to just give you a feeling for what we did at this university that will help. Yes, sir.
Yes, and what about 3D printed food?
Food, very good.
Pizzas.
Chris is going to mention that, yes.
Okay.
Chocolate, confectionery sugar, so you make your own candy. Did you say pizza? Okay, so Florida Polytechnic. In the state of Florida, there was 11 state universities, 11. And the governor said, we're going to make 12, we're going to make one more, it's going to be STEM-based university. And so they hired somebody to start the planning. That person hired me, as well as some of the other folks. Fishhock Commission was one of the first professors at the university. And we came up with a mission and vision, a strategic plan, and how are we going to put this campus together with academic programs and technology industry collaboration. 500 acres, about 30 miles away from here. In that plan, it included yes, we could 3D print this if we had the time. Business plan highlights. We needed innovation. The reason to start the university is to do innovative things, do things different than any other university in the state, or else why bother having a new university? Cutting edge, integrated campus, create a high-tech corridor. Innovation needs capital, infrastructure, and so forth. This is all in the business plan of the university. The university will leverage technology, highly sought after technology in the 21st century. So again, what the governor wanted was the answer to the question, why is this university going to be different? Now, he started the university, well, him and some other politicians. But it was up to us to say, well, here's how we're going to be different. So we had to create innovation labs that were high-tech and that were going to be integrated into the curriculum, into the educational courses. So we did some very unique things in terms of digital library, supercomputer and high-performance computing complex, student data center, students could access the data center. And then this is the RAD Makerspace. This is the 3D printing environment. It stands for Rapid Application Development Makerspace. You guys have heard Makerspace? You've heard that word? Neither, I know, right? It's like Makerspace. Well, what are you talking about? Makerspace. But that term has been around, again, for a lot of years, but it's typically for some place they may do woodworking or make typical mechanical things. Here, 3D printing is now taken over the word makerspace. So when people hear makerspace, they start to think, oh, that's where you have your 3D printers. So, and then we created these other innovation labs here. Our main building, we have 7 buildings on campus. Our main building is this big building, and right here, right in the middle of this building, is the 3D printing RAD Makerspace.
So when did
It started 2 years ago. Yeah, about 1,500. Yeah, so we started with 500, doubled the second year, and the third year we're doubling, well, adding
Where do the
500.
students come from? Mostly Florida?
Mostly Florida, but there's New York, California. We're now getting into international students, so there's more of that. Here's the programs: College of Engineering, College of Innovation and Technology. The goals is that we wanted real-world, hands-on, critical thinking experience, internships that could translate into the industry. So students learning CAD, computer-aided design, can translate that skill into industry, which is a very highly sought-after skill. And the design methodology, which Chris is going to talk about, is how those students can integrate those technology concepts into a design methodology. Entrepreneurship, applied research. There's things that we've created with 3D printers that can be sold as products based on courses that Chris has taught.
Can you give examples?
Yes, we'll give examples. We will. Couple of pictures. Here's, this is an outside view of the 3D printing makerspace. So these are all desktop 3D printers that are here in this lab. Over 60 of them. This is another view. Again, 3D printers here. This is a Stratasys high-end 3D printer. That's $50,000. The types of printers that we have: MakerBot, Replicator 2. That was the previous generation. That was the 4th generation of MakerBot 3D printer. We now have 5th generation, latest generation MakerBot 3D printers. They're about the size of that printer, about this big. Formlabs, that's a printer that actually uses liquid polymer, and Chris will actually discuss this, and a laser that creates the object in the liquid polymer. That's this printer here.
What generation is that?
That's current generation. That's the latest generation.
What is it, 5, 6?
Well, it's 5 as it relates to the MakerBot. Yeah, so think about it as 5th generation. We're in the 5th generation. And then the Stratasys printer. This is a medium scale printer. Again, it's about $50,000. Can print objects at a very low level of precision, or I guess high level of precision. Very high level of precision. Okay, so now we're going to talk about,
Is that the name of the university, Florida Polytechnic?
yeah, Florida Polytechnic. Yeah.
You're the one that did the Crescent Wrench, I saw that about a year and a half ago on YouTube. Somebody
Yeah, we've created
a Crescent Wrench.
yeah, a workable crescent wrench.
Yeah.
And that's made all layer by layer.
Yeah.
It doesn't stop. In about 2 hours, you can make a crescent wrench.
Yeah.
And it's just layer by layer, and it knows the right gaps and tolerances, that when it's done, you take it and you can actually move it. You can move the parts.
You're the one that created the video, I guess, of that there.
Yeah, I created several videos. Okay, so we're going to talk about additive manufacturing. Am I going to start? I'll start talking about it. I'll start talking about it. So one of the additive, again, manufacturing is 3D printing. Again, you're adding layers to make an object. It's a low cost. Now, with desktop 3D printing, very low cost. You could conceivably consider having a 3D printer in your house, and you can go to the web and get objects. There's 1 million objects that are available on the web that if you wanted to create a cup, right? A cup or a spoon or a fork or something like that, you just make it right at home. You just download the object and print it, right? So here, you've got the filament right here. and it'll make the object in about an hour.
How durable are those, let's say I'm at a floor, how long would it last?
It depends on the filament, but in this case, this is PLA filament, right, Logan? So, it's not metal, you know,
It could be metal.
but it could be metal. In the case of PLA filament, Logan, how long do you think that for would last?
10,000 cycles probably.
Yeah.
Depending on how often you use it.
Yeah.
Oh,
10,000 cycles. Like
10,000 meals, basically.
Yeah.
Yeah.
10 years,
Yeah.
1,000 meals a year.
Yeah.
10 years.
Low cost capital, and you could make items that are difficult or impossible to fabricate in other methods.
So what you do, you go down to the local Costco and buy about 80 barrels of PLA, or PLA with plastic,
Yeah.
take it home,
Make your own stuff.
tell her coffee is coffee.
Yeah. Amongst other things. So, okay. Do you want to jump on this?
Sure. All right, so there's a number of applications. This is again from the Gartner study that was published in 2014. And they queried companies mostly about what they saw as applications for 3D printing or additive manufacturing in general. And the biggest applications at that time that companies saw were in prototyping, which they have already been doing for a number of years, product development, and innovation, where they're coming up with designs that can't be made with traditional manufacturing processes or even machining processes. So that accounts for over half of what companies saw as realistic applications for 3D printing. And then there's a whole mess of things that people are thinking about using it for, but many of these have not really even been explored yet. And so what the report also did was convert this pie chart into what's called a hype cycle. So we're going to spend a few minutes to try and understand this graph. Basically what it tells you is this y-axis is the expectations of either the users of the technology or the consumers of what comes from the technology versus what's usually time, but this is written out as there's something that happens early on. There's thousands of reports in ABC and CBS and NBC and CNN talking about how fantastic this technology is. So that's at the peak of this hype curve. And then reality sets in. There's a trough of disillusionment. This is common to all new technologies. And then slowly people learn enough about the technology to find applications that are real, that make profit or that are helpful for people. And then on this hype curve are shown a number of those applications and where Gartner thought that those applications sit on this hype curve as of 2014. So some of these, like 3D printing of consumable products, consumable meaning edible, is way down at the beginning of the curve, and if you look at the dot, it's a black dot or a blue dot filled in, which means it's at least 5 to 10 years out before it's going to be over here. There's other things like 3D printing for prototyping is already out on this flat plateau of productivity where it actually has been demonstrated to be helpful. Okay. So I'm going to talk a little bit about the 4 circled areas on this graph rather than trying to talk about all of them. So we'll talk a little bit about prototyping, a little bit about classroom 3D printing, a little bit about intellectual property, because we're now running into the same issue that happened when VCR machines came out and people were copying movies. And then when CDs came out, people were copying music. And then when BitTorrent was created and they're copying everything. You can download it for free. Right. So there's a big nest of issues that need to be explored and resolved here going forward with 3D printing. Are there any questions about this curve? It's a very interesting and useful curve, actually.
What's the name of the curve? Is it called the hype cycle?
It's called the hype cycle.
Okay.
Stuart Gartner.
Gartner's the consulting company that came up with this report that uses the life cycle. I don't know if Gartner came up with the name or.
What happened in the control of dissolution? Why did people give up and why?
Trough of disillusionment?
Yeah, what happened, and why they give up, and why they come back?
Why does this happen?
Yes.
Because there's tremendous overselling of the technology here.
Right.
Right.
What is the time cycle for all of this? In other words, when, is this for each product or?
So it depends, right? For 3D printing of chocolate, they think it'll be 5 to 10 years before it gets here. For 3D printing of medical devices, right now it's at the peak of the hype. And they're predicting within 2 to 5 years it's going to be standard.
Have you heard of, at least I heard, I don't know if it's right what I'm gonna say, about making bridges with 3D printing?
Bridges?
Bridges?
We'll come to that.
Oh, okay, sorry.
Professor.
And houses.
We'll come to that too, yes.
So at what point technology will be developed to prevent that the terrorists start using that technology to develop weapons that cannot be detected at airports and things like that?
I have no idea.
Is this anything going on
Very
to
good.
prevent it?
I'm sure they're not aware.
If he got the idea, he would be a billionaire.
Maybe Donald Trump.
Other questions? This is probably one of the most important graphs for the whole presentation, so if you understand this one, you've got a lot of it.
So it doesn't seem like, I'm not quite sure why there's going to be a trough for the medical devices, because I've heard they're so effective and it's so exciting that I don't understand why there will be a trough.
So, similar things have happened with like hybrid electric vehicles. Right? There was tremendous excitement about these in the 1980s, 1990s. There were some products that came out. They were disasters from the consumer's experience standpoint.
I see.
And there are going to be things like that with medical devices also.
I see.
Because
So,
it's new and
in other words,
we're-
I shouldn't go ahead and get a 3D printed hand.
Well, hopefully you don't need it.
I can wait for the next cycle.
But that may only be 2 or 3 years away.
Okay,
So-
no, I'll keep my hand very close.
With the weaponry, there was a problem 2 years ago. I started reading about this, and evidently people were beginning to manufacture handguns.
Yeah.
There's a big flap in this country about that, and they were making them out of ceramic.
They are doing that.
Do they work? Would they work?
Yeah,
They can get the damn thing to work, that's the
Yeah.
problem. So I don't know if they so if you can prohibit stuff like that, well, how much good, so the internet is why we want to call it internet. You can get that, the CNC version of it, and if you have the ceramic loaded in your reservoir, I mean, you can still print it regardless of what the US government says.
So that's a very interesting point, because I can also, I was able to before go out and buy a nice 5-axis CNC machine, set it up in my garage, and then download data files that show parts,
Yeah.
machine them at home, using subtractive information processes. So this is the same idea, it's just it's adding things to subtractive.
Now, that, the reservoir, I mentioned ceramic, we mentioned metal and stuff like that, so I guess it's gotta be in a liquid form, whatever you're using. No.
Maybe. So I'm gonna pass around 3 samples of parts that were made with 3 different technologies, and we'll maybe get to what those technologies look like. This one was actually printed last week from a vendor in Pinellas County, which is where I live, which is just west of here, about an hour and a half. That's ABS, which is a plastic which they use to make Lego blocks. Yeah, so it's the same material as Lego. This is a part that actually has a movable piece in it, which is called laser sintered, or selective laser sintering, which uses gypsum. Actually, this one is not laser sintering. This is gypsum, which is glued together with an adhesive that's then UV cured. And that's 3D printed. And then this is a item that was printed by the Formlabs printer that Tom already showed an image of. So this uses the liquid polymer as a starting material and then exposes it to a laser or to an image, two-dimensional image to generate a solid chunk of material that's smaller. So you can get a flavor for the resolution that's capable of doing, the textures that you can get, the types of different materials that you can get out of it. You have a question?
Can you use different material?
For this printer,
No, this one no, but.
in general, yeah,
Maybe
there's.
another generation or maybe.
Sure.
Do you have a 3D printer that can use two different materials?
Yeah.
Or just not?
Yes, yeah, there are printers that can do two different materials. MIT just announced that they have demonstrated a 3D printer like this one that can do 10 different materials in one object.
So you can use a conductor or.
Conductors, insulators, transparent, flexible, rigid.
What did you say was the format here in this one?
Well, it's a translucent material, and that's the one that starts as a liquid, and then a laser is selectively positioned in order to cure the material.
How about the ceramics?
So you can do electronic?
The ceramic is gypsum powder that's glued together with.
Okay, so it wasn't for powder.
Yep, yeah, and we'll talk, hopefully we'll get some talk on how that machine works.
It is possible to make electronic.
People have demonstrated simple things, yes. Yeah.
Okay, I'm just in the last part of the graph where the gradient is almost zero, which means there is saturated excitement. I'm wondering what could be the cause for constants in appetite or expectations vis-a-vis the cost benefit analysis, because in that time we expect that it must be cheaper to own the 3D machine and to do your own stuff than otherwise to have to buy it from the different manufacturers.
So that's a very difficult question to answer because it depends on what you're trying to do. It depends on what's available right now as a competitive supply. So if you're doing one unique item for you, for your desktop, then 3D printing is an excellent way to go. If you want to make 10,000 items of your head that you then sell on eBay, then 3D printing may be not the best way, not the cheapest way. Because you can order a mold and have an injection mold, especially in China. So it depends on the application, on whether 3D printing is the right choice or not. And really, if you think about this y-axis being expectations, it's not even shown whether that's linear or logarithmic. And most of the stuff that you buy nowadays at Walmart or the grocery store, you have nominal expectations for it, right? You expect it to work. You're not excited about it every time you go buy a jug of milk, right? The plastic jug is just part of life now, so.
The 3D plastic drum,
Questions?
I just wanted to share my experience using 3D printers. Because I work in a laboratory of aerodynamics in Venezuela, which I found that it's not as big as yours here. But yeah, we used to build the wings of the planes with wood, of course, right? For RC modeling and so. But when we checked another way of building this, it changed completely the way of producing the prototypes. It's faster, the size is much more precise, and also the finishing of the shape is also much better. The only drawbacks that you have with these 3D printers, in my opinion, when building this, is that when you're going to build a wing of the airplane, it's such a big thing, and as you can see there, it's only the space is limited, so you have to build it in several parts, and then you have to get them together. So you have to paste it, and then you can lose a little bit of accuracy when you do that. But when you are working with scale models, it's so good because you can build it there and then test it in the wind tunnel. And the other thing we bought is a 3D scanner as well, which is like the opposite procedure. Yeah, with this one you just print it, but with the other one you scan it in 3D.
and it's been a good asset for the lab, the 3D printer and also the 3D scanner. And much more things have been built in this, like weapons as well, and some other devices to attach to another product. And the experience has been very, very, very good. I think that in the field of mechanical engineering, all the students must already know about the production of pieces or components with these machines and how to work with them. So it would be a good policy to include in the careers.
As part of the core curriculum.
May I make a comment on your comment? Your experience is not generalized experience. I would say that probably 90% of the university, they don't have a lab. It's not an academic problem in this moment, as they said, regretfully, because we invested a lot in having, some papers and 3D printing and technology, and we got no submission at all, because the people that we are related to are academic people. So I contacted some of them about that. They didn't know what I was talking about. So it's like what you are saying, but it's not generalized in the academic world. I don't know why. So this is why we wanted to do that here.
So can I make a comment to your comment?
Yeah.
Generation, no, okay.
Gen 3. So I was at the American Society for Engineering Education annual conference last week in New Orleans, presenting one of the papers we presented was actually part of this talk. But I went through the conference papers and pulled out topics that were presented either as papers or posters that had 3D printing involved, and I found 10 papers without looking hard.
That's a lot.
So there's a lot of
It was
activity.
an
just
industrial meeting, corporative meeting, corporations, or academic meeting?
Academic. This is
Okay.
strictly engineering education. So
Okay.
it's the
Yeah.
annual conference. Yeah. The 123rd annual, 124th.
I'm still looking for examples of, where this is used for a sort of category, but can you tell me something like pens or something like that?
One example is dentistry.
Dentist.
So dentistry right now in healthcare is the most common form. So we're used to take a couple of weeks, orthodontics especially, you take the mold of somebody's teeth. And in order to prototype that and be able to analyze that in terms of how you want to treat that, it would take 2 weeks. Now, you can just, a couple hours later, you can scan that and have a 3D printed version of that mold.
Because of other other examples?
Where 3D printing is actually being used.
Yeah.
GE just announced GE aircraft engines. They have certain parts that go within or on the turbine blades of jet engines that are almost impossible to manufacture using conventional technology. And they have now announced that they will be making 20,000 or so components with 3D printing using metal powder process starting next year for GE aircraft engines. Now, they started on that process 20 years ago to develop that process, so they have a trade secret process. You can't go buy a 3D printer that does GE aircraft engines yet.
You answer this guy's question. You said the printing, MIT is printing a house or building?
MIT has a printer that can print 10 different materials within the same object, but there are other people that are printing
Construct a house with that.
Yeah.
Okay, is that right? Because
Yeah.
I saw it on TV. Is that right that the bridges with drones are being built with 3D printing?
We have
With the
pictures.
drones, going around them,
Yeah.
and then the 3D printing was printing that. Is that right?
I don't know.
With
I saw
drones?
that.
The drones will be scanned.
I saw that video, yeah. But it's just a show how they can command the drones in order to perform an activity of building something. So every drone has a 3D printing machine, and so every drone was adding material.
Okay.
The end was building the thing.
Okay.
But-
I thought I was saying.
Yeah, yeah.
What are some of the risks? The risk, general risk with these printers?
With this technology?
Yeah.
Well, the nice thing about the materials.
Based on the type of material used or.
Yeah, most of the materials are either, the PLA is recyclable, actually. It's a plant-based plastic, which is the filament that you see on this machine. All of the materials that I've seen people use for printing are safe. Nothing toxic at all.
In a paper. In a paper. You can use it in 3D printing.
So there were some old 3D printers that would take a stack of paper and then laser cut each layer uniquely and then glue them together to form a 3D object. That's a
Very old.
What's the prevent counterfeit?
there's a lot of counterfeit, anti-counterfeit devices within paper currency.
I know that, I mean, ultimately, those things that people
I don't know. Other questions? Yeah.
So I think as a risk, we may consider the possibility to print guns. It may be very, because I know it's possible to print guns in plastic materials, and if this technology is going to develop, so I mean in the USA it's different, but in Europe we have very strong controls about who is holding a gun, and with this technology we can completely cancel the regulations and any kind of controls about gun production. Yes.
Yeah, there's going to have to be some controls put in place eventually, and that actually comes to the question of the intellectual property associated with the files, right, that describe the objects, and whether there will be some sort of regulatory control over what content is in the files. So if it's pieces for a weapon, for example, those files may be made illegal, and then there'll be some control put in place to control access to them.
Well, we still have good hackers, you know, to.
Oh, yeah.
Like
the regulations are really good.
Like with computer programs, most of them are not copyrighted and mostly on public.
Yeah.
It's just a program on how to do things.
Well, it's a design actually, right? So there's actually intellectual property involved.
If I write a computer program, I mean, can I in any sense say only that program?
Sure. Well, you can copyright it. Yeah, well, software patents again are almost impossible to get rid of. Logan Miker, who's a student at Florida Poly, sitting almost next to you, he's been doing designs of robotic parts and kits for a summer program that they run at the university, and those designs are unique to him, so he actually has a copyright on the design.
You could patent a program to your flow chart, and you see what goes on that.
So this is actually not a standalone program, right? This is just a file that was created in AutoCAD.
Did you show a picture? Do you have a picture, a drawing that you can show of the path in 3D?
We don't have one here.
Are you going to demonstrate this today?
It's not functional work, unfortunately.
Yeah, it will take at least 2 hours, the demonstration.
What is the challenge for 3D versus 4D now?
Versus 4D?
4D printers and what's 4D? 4D is another dimension.
Yeah, I don't know what 4D is.
Do you have any challenge from the 4D?
So what is 4D?
Google, then there is a 4D printer.
So what's the fourth dimension? Is it different material types? Maybe yeah, normally time. Okay, let me move forward here. So, in terms of services, that are provided with 3D printing. If you don't want to go and buy a 3D printer, you don't care about how it works, it's not yet available as an iPrint 3D device that you put up to your iPhone. There you go. You can either download a data file or create your own data file just by doing it, and then upload it to one of a number of websites. And this one here is called 3D Hubs. And the interesting thing about this website is actually created by a person in the Netherlands. And 2 weeks ago, I submitted the data file for that black object, that ABS object there, to a local vendor, and had it printed. It took a week, because he went down on vacation for most of the time. But the interesting thing here is you go onto this homepage of 3D Hubs, and here's the number of vendors that will be willing to give you a quote to print your object.
How much is that for?
That piece was $12. That's a custom, unique part for me.
Both of them.
Does that include shipping and delivery?
So he's close enough that I just drove over and picked it up. So I stopped at the pet store to pick up dog food, and then stopped by him to pick up food. So,
I'm not interrupting him for that because
so that's a spaceship.
What?
Spaceship from a TV show that my brother wanted to print it to give to his son.
All right. Suppose I go around and I have a whole car and I start working on it.
I necessarily need to ask you if it's possible to lower the voice of the communication between, in order to have his voice clear in the video. So I'm sorry, but I know that what you're saying is so good that everyone is talking.
Well, that's the idea.
And they are sabotaging you, with the video. Please.
Just had an empty car and I see it. This con. Pull apart out there and it's flat, it's great. So you even want $600,000 for it. I just take these cars down, and is there any way I can get on this website and find it? Is you got to the point where we can find and take the parts for cars?
So it wouldn't be on this website, so there's other websites where you can find this type of parts.
I just scan that thing perhaps and then just program it and then I'll pay dealers with that.
And there are people talking about the business model where in AutoZone, printers for plastic panels and so forth. So you go there, or you go on their website and you order the panels that you need replacement for, and they print it locally and shoot it later.
Some of the places are made it.
So as long as somebody can design it, yeah.
Have the old car. Take up the teeth, run with it.
Right, so he, as we said, he had a 3D scanner that would scan the in, and then once we record it into that program, we can modify it.
Okay, the fourth dimension is basically the shape and the strength.
Fourth dimension is shape and strength.
It changes the shape and strength is with the context.
Okay. So, food, everybody very interested in food because of Star Trek mostly, where they had food replicators back in the original series. Chocolate is of extreme interest right now because you can print custom chocolates to give as gifts, for example.
How do you make it? Do you use chocolate instead of polymers?
Exactly.
And so one machine does take a liquid chocolate and carve it using a laser? And
It'll actually deposit, just like this machine deposits the melted
With layers.
This layer deposit melted chocolate.
and you have a piece of chocolate in the mouth.
And have a message on it or have a unique shape or and print would be 24 of those on the same print run. You're not limited to print one
Cheaper than traditional chocolate.
And if you're gonna do one is cheaper. If you're gonna do just one, it's cheaper.
Yeah, and each one unique one is used. So there's a number of technologies and regulatory hurdles and so forth that are already in place in the food industry. So as long as the 3D printing people follow these requirements, then this will be approved.
What is that last line that says capacity 30?
So I didn't want to focus in on this, but So you need reliable, consistent hardware if you're going to put this at the grocery store bakery. They're going to want to know that that printer is going to work today for 12 hours right now. So that's revenue for them. And right now, these types of printers here have an uptime of about 30 or 40%. So it's about 60 or 70% of the time they're being repaired. Doing what? Being under repaired. Being modified.
Oh, I see.
Something's wrong. So, that number needs to come up so that people who are going to use these printers for revenue generation can rely on them.
So as a specific comment to that, this 3D printer, the reason it's currently not printing is because it's actually under repair by me. This is the one I use at my home. I do custom 3D prints for people as well as for a couple of little shops around me that sell some of my products. I can tell you 30 to 40% may be like the really expensive ones. I didn't have the money to buy a really expensive one, so my uptime is really about 20%. If I'm lucky, I'll get a couple prints in and then have to spend a couple of days fixing it, replacing parts on it. I mean, when it works, it's phenomenal, but unfortunately, it's not working a lot of the time.
So how often do you have to redo a print across a case?
Normally, not very often. It normally fails between prints.
Okay.
So something will jam in it, and then I can't get it started.
So in my experience, I have to redo the model more than like 35 times to get it working printing. That's maybe because my experience was
Yeah.
so great, but in our experience at the university, this is really a problem.
Yeah.
So we have to learn a lot about the software to get a model out of printing.
Can you have spare 3D printers so that you can print the parts that break?
If I had enough money, that would be phenomenal. I'm also a student currently, so money's a little bit tight.
Can you print a 3D printer using 3D printer?
So some of the components on there, do you mind if I go ahead? So some of the components on here are actually currently 3D printed. Obviously you can't do, with the printer as cheap as this one, this was about $500. You can't print the metal components, but you can print stuff like this top, right? So that's what holds all the cords in, and then I can't currently take it off, but this piece here is also made out of the same materials, PLA, the organic plant-based plastic. And it's what guides the filament down into the hot chamber and then out the nozzle. Also, this component on the back here that I use as a clip to hold the tube a little bit more fixed back here. So a lot of the stuff on here has been 3D printed to be used on the 3D printer.
Is PLA expensive? How much does that cost?
So for about 1 kilogram, which for the Americans is about 2.2 pounds, is you can get anywhere from $12 if you buy the really cheap stuff, or $50 if you buy the stuff that's outrageously overpriced. But about $20 a kilogram would be a fair price. And that'll do, you'd fill up this whole print bed at 10% infill with a kilogram.
Okay, so we're over time already, I think. It's after 3. What do you want to do?
He just left. Okay. Yeah, there's a 3:30 on the agenda for today?
3:30 is refreshment.
Oh, it is?
So what, there's nothing until 3:30?
So we have 20 minutes. There's a couple of things that if I don't say them now, just to write them down. We talked about where you can find some of these already created designs. 2 websites. One is called GrabCAD, G-R-A-B CAD. That's a place you can scan hundreds of thousands of different objects to be able to find something that's similar to what you would want. Or Thingiverse. The other one is Thing, iVerse. That's got over 1 million objects. So, the countless number of applications, as Chris had just mentioned, and you can find these objects, download them, and then send them to a printer to actually make, to make them. So we do in our lab.
Check the program, 3 to 3:30 is our coffee break.
3 to 3:30?
And 3:30 is another panel, so.
Okay.
I don't want to tell anyone not to have coffee, but.
Yeah, so we'll wrap up. We'll wrap up here.
And can I ask one more question?
Please, sure.
Is there any connection or thought about a connection? I've heard that there's a lot of, the CAD, the computer aided design is now being used for architecture. Just, okay, here are the features I want in my building, blah, 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 and then the building gets designed based on the specifications.
Very good. Yes, exactly. So architects
Right.
love 3D printers. And as Chris had mentioned, engineers, people in the arts now are actually creating art based on things that they've used their CAD software. So they draw it out in their CAD software, save it, format it, and send it to the printer, and that's their art.
And then they create it, yeah.
So it's a different way of sculpting,
Yeah.
I guess you could say,
Right.
right? Architects and engineering, so we talk about prototyping, where you can take what you think is the right part and you prototype it. And even so, you can have prototypes of prototypes, because it's so inexpensive. So Lockheed Martin, for example, several folks in their labs, they're creating special DoD jet fighter applications. Chris had mentioned GE aircraft engines. But Lockheed Martin engineers will use their 3D printers for prototypes of what will become the prototype that will be tested. And they can go through several iterations very inexpensively, cheaply, with 3D printers. So that's again, the growth of the 3D